so let's go ahead and jump into Cisco Packet Tracer. So I have it opened up here. So I'm just gonna also pull up the diagram that I have just to make sure that I'm following it, that everything matches, right? So I have two PCs, myself here first, and then I'll move myself back. PC, okay. Change the display name first, just so that's easier. There we go. Add a switch on there. Okay. I'm gonna connect them, right? Connect the ports together. Connect from PC1 to PC to the switch, and then the switch to PC2, right? Let me go ahead and add just some text boxes so that it's easier to read. Let me also zoom in. 168.1.12. That's the IP address. Right, that's the IP address. MAC address. Okay. And also subnet mask, right? /24. St. Mass 255.255.255.0. Right, and its MAC address. I'll add that in a second. And really quickly, let me just copy this so that I can put it over here. This one is going to be .25, right? Same subnet mask, and the MAC address will be different. And right, this is a subnetwork. /24, right? And let me go ahead and just add this in here to kind of help just seeing it better. Okay. Right? Okay. So I want to go ahead and look at what the MAC address is for PC1. I'm going to type in the command ipconfig /all. So this is its MAC address, right? Listed here as physical address. That's its MAC address. Okay. So I'll go ahead and type that in there. Okay. Okay, PC2, same thing. ipconfig all. Okay, physical address is that. Copy that. Okay. Nice. Okay. So we're ready to we're ready to start the ping, right? So we're ready to ping from PC1 to PC2, right? So what I want to show first is I want to go ahead and first just show you what the ARP table looks like for PC1, and I'll show you what the ARP table looks like for PC2. And then I'll also go ahead and show you just the MAC address table for the switch. So let me go ahead and show you the ARP table, and this is for PC1. As you can see, it is empty, right? So we have an empty ARP table for PC1. Let's go ahead and take a look at PC2's ARP table. Same command, arp/a, empty as well, right? And the switch, we're going to go to the CLI, enable it. Oh, accidentally put an M there by accident. Okay. And then show MAC address table, right? Nothing on there, empty, right? So we have an empty MAC address table as well. So everything is empty, right? So we have empty ARP tables for the PCs and empty MAC address table for the switch. I'm going to go ahead and open simulation mode on here because it's really going to help us when we're looking at just the ping and what is going on, right? We already described it in the slides, but I want to go ahead and just show you what it looks like on Cisco Packet Tracer, right? So I'm going to ping from PC1 to PC2. I can also ping from PC2 to PC1, right? So it doesn't matter which one you do, but I'll go ahead and do PC1 to PC2. All right, so ping, and the MAC address that I want to ping is, give me 1 second, actually forgot to configure the IP, so let's do that first before we ping, right? So that's for PC1, and this is for PC2. Let's go ahead and configure the IP addresses. Right, okay, awesome. Okay, so let's go ahead. Let me just, oh, 1 second. Okay, so let's go ahead and do the ping now, right? So I'm pinging from PC1 to PC2. That's its IP address, right? So we're on simulation mode. Let's go ahead and see what's going on, right? So it first tried sending out the ICMP echo request, right? As we discussed, PC1 tried sending out the ICMP echo request. So it creates it, right? The ICMP echo request is created at PC1. However, our ARP table was empty, right? There was no entries on that ARP table. So what is PC going to do? PC1, it's going to go ahead and create an ARP request, right? So creates the ARP request, it sends it to the switch, right? Right. So the ARP request is sent out to the switch, right? And then it goes ahead and sends it out to PC2, right? So PC2 receives the ARP request from PC1, right? PC2 is going to go ahead and send the ARP reply, send it to the switch, and then it's going to go ahead and send it to PC1. Now, as you can see, we start the ICMP echo request process, right? So we start the ICMP echo request process. You see now that PC1 is going to send the echo request to the switch. The switch sends it to the PC2, right? And that's because the switch learned PC2's MAC address when it sent out, when PC2 sent out the echo reply, right? Switch learned PC2's MAC address when PC2 sent out the echo reply. Sorry, the ARP reply, right? PC2 will send out the echo reply, sends to the switch, and the switch knows PC1's MAC address and the port that it's connected to, because when it sent out that ARP request, it learned it, right? And then PC1 receives it, right? And you see, slash, and that's the ping, right? And let's go ahead and look at the message, right? So it says, it got a reply, right? From the destination IP address, right? 4 packets were sent, 4 received, right? Nothing was lost, right? So it was a successful ping, right? Let's go ahead and look at PC1's ARP table now. What do you see here? You see PC2's IP address and its MAC address, right? And that matches what we have right here, right? Same thing, right? Let me show you PC2's now. Let's go ahead and look at, remember, we had previously no entries. Now what do we have? We have the IP of PC1 and its MAC address, right? I'll go ahead and show you the MAC address table of the switch, right? So nothing was on there previously, right? Now, if we look at it, you can see the MAC addresses of PC1 and the MAC address of PC2, right? We see both MAC addresses and the ports that they're connected to, right? This is port fast Ethernet 0/2, port fast Ethernet /0/1, right, for PC1, right? So all of that is populated, right? So let me go ahead and do the ping now from PC2, hop back into simulation mode, and it's going to be different, right? This isn't going to look the same as when we pinged from PC1 to PC2, right? And what's going to be different is that we already know the IP address and the MAC address of PC1, right? It's in our ARP table, remember? It's right here. So we're not going to need to send out an ARP request and wait for an ARP reply, right? We're just going to immediately send out the echo request. And let me go ahead and show you what that looks like, right? So let me ping, right? So, right, let's see, no ARP request sent out, just the echo request, because we already have the MAC address of PC1, right? PC1 responds, grabs it, right? Quick. So it was quick, right? Because we didn't need to send out that ARP request and wait for that ARP reply, right? And then the switch already knows the MAC addresses, right? Because it's in its MAC address table, right? So back to real time, you can see, right? Successful ping, right? PC2 had a successful ping to PC1. And as I said, we didn't need to send out an ARP request and wait for an ARP reply because we had the IP address and the MAC address of PC1 already there, right? And if we do the same for PC1, you'll see that we don't need to send out an ARP request, right? Let me close this one out so there's no confusion. Okay, right? Let's go ahead and observe, right? So, right, no ARP request is sent out, right? Just an ICMP echo request, because we already know the IP address and the MAC address. And we go ahead and receive the echo reply. Successful, right? And we'll go ahead and get just that message that the packets, 4 packets were sent and 4 were received, right? Successful ping, right? Right, so that wraps up just communication when devices are within the same subnet. The next video, we're going to go ahead and go over how communication looks like when devices are not within the same subnetwork, right? So that's when we'll go ahead and see just routers get involved, right? All right, so thank you for watching. Stay tuned for the next video.